Before we can start an ecological model, we need to be able to create random rasters, because in every ecological models there will be some random processes that we have to embed into our model. So there are three different ways how you can create a random raster in ArcGIS Pro. The one is that under your spatial analysis tools, if you scroll down there under raster creation, you can create a normal raster and a random raster. I will create both of these and show you the difference. But just while we're here at the toolbox, I also want to show you, if we are searching for random, you can find a create random raster tool under data management tools. And if you open up this one, then you can actually choose what kind of statistical distribution you want to use. Do you want to use a normal distribution? Do you want to use a Poisson or exponential distribution? You can choose which one you want, and then after that you can then set your distribution parameters and of course your grid cell size at numbers and rows and columns. So here I want to show you first of all the random distribution. The random distribution creates a raster that is between 0 and 1. So this is a very, very small number, and this is a number very close to 1. And the values inside our random raster are evenly distributed. We can see that by going to our symbology and by simply looking at the histogram. So there you see, of course, it's random, it's not perfectly even, but if you had 1 million points or 10 million points, you would come up to a very, very even distribution of all the values between 0 and 1. Let's look at the distribution of the create normal toolset. There we see that whilst we are using the same symbology, the distribution of points is very different. We see only very few points that are very high and very few points in reddish colors, deep reddish colors, that are very low. In this case, these values are our Z values of our standard distribution. Again, going to the symbology, we can see here is our standard distribution. We will have a lot more values. The lighter yellow to bluish colors are much more frequent than the darker colors of our extremes. So for our model, I want to create a random raster because the random raster lets me quite easily choose a certain percentage of my points that then are randomly selected. For instance, I could use all the points that are over 0.9, so the top 10%, or all the points that are less than 0.2, which is the lowest 20%, or anything in between. Let's implement this into our model. Let's build an ecological model. This model is based on the idea of the life model, where we have a plant here represented by a green grid cell surrounded by soil, and these plants will provide seeds, but then there also is a die-off rate. And we will see as we iterate from year to year to year how the distribution of the plants will behave based on selected input parameters, either the number of seeds that survive or the die-off rate. Let me show you how this works in the model that I already built in the ModelBuilder. We don't need the toolbox here right now, and I want to see these two side by side, so we'll drag one of these to the other side. At the moment here, we iterate 20 times, so we're simulating 20 years. I will actually only going to run this now for the demo purposes for 2 years. Let's have a look at the workflow of this model. We're starting off with a raster file called annual. The annual file, if I go to the properties, we have 100 columns by 100 rows, so 10,000 grid cells, each 1 by 1 meter in size. The first thing we do, we take our raster file, which was randomly created, so every grid cell here that is in green has a value of 1, and it represents a plant. Everything else around it is bare soil, has no color. So the first thing we do is we're spreading our seeds, and we use the expand command for that. Expand command has the input raster as an input file. I create a new output raster, and it spreads it simply by 1 grid cell in all directions, and I would hit run. The result looks like this. So all yellow areas now are seeded. So let's see then what the next step is. So here is our seeded file. I call it expand here, and now I'm multiplying this with my seed survival raster, which was created using the create random tool, and then selecting all those values over 0.8. So basically I selected 20% of the points as being ones, and then the rest was zeros, and that is my seed survival file. Let me show you how this looks like. All now symbolized in green would live, and everything under white would die off. So if there is a survive and there's no seed, nothing will happen. If we have a survive and there is a seed, then the plant will grow. Let's zoom into some area here to look at some details. So this seed survive is then multiplied with our seeded areas to create our first new annual raster file. We're doing that in the raster calculator and simply saying expand times seed survival. Right now here in ArcGIS Pro, in our model builder, we use, instead of doing this, we simply use the times command. And here the result of the new annual A in a lighter green, it would be now covered by the survival ones, so I can turn this off. And so here now we see those randomly selected locations where the seeds are surviving and a new plant will grow. These will now have to be added to the existing plants. So this file plus our existing one will create annual B. Again, using the raster calculator, we would just add them up, and the equivalent for that is the plus command in the model builder. So I'm turning off the seeded ones. We don't need those anymore. And here we have our new annual B. You see that they're overlapping, and we can see here that the results can be zeros, ones, or twos, and the reclassify command can rectify that. That's where we now use the reclassify command to simply make ones out of the twos and create that now annual C. Here you see zeros stay zeros, ones stay ones, and two become ones. No data is no data, so that's just all we're doing is converting the twos back to ones. All one color, this is what we want. And then the last part is that now we have die-off happening. And the die-off, again, as the seed survival raster, was created by using the create random tool and then simply querying, in this case, the top 4% of all the values and creating that new raster. That raster looks like this, where those cells are symbolized in red where we have plants dying off. So then the die off raster will be multiplied with the last new annual to create our first final annual plant result. Again, looking at the raster calculator command, simply a multiplication. Same thing here using the times. The 2 here is simply an indication that times is used the second time. And the result of that then looks like this. So this is our final result. And then this final result simply will get some symbology, and with the collect values and the output values will then be added. And then here we see the important feedback connection between the first result, and we're feeding that back in here. So the first annual now is going to be replaced by this one, and then we're expanding this one and doing all the same logic again, year after year after year. This is the only layer that is added to the display, and all the other layers, irrespective of where we are, we do not add them to the display. And most of these layers, we could actually also say delete the intermediate data so that it doesn't keep all those values in your folders and in your savings device and blocking up memory. If you had a very large file and you iterating, let's say 1,000 or 10,000 times, you don't want to create all those files. So let's run the model. I'm only running it for 2 years. And we can see that first of all here it created already the random values. It does the con command. It does everything here. And now it needs a second part here. So it runs, it travels around. And you can see now it already has added here our first layer. It is not visible yet in our display. That will only happen at the end of the run. This is currently not automatically refreshed. But the new layers are added, as you can see. And there's the end of our run. We created these new layers. 3rd year on the right, 2nd year, 1st year, and 0 year. So now let's look at our results. We have all the same symbology because we have coded it this way, and I can turn all these off. So here is year 0, the first year that we do, and the model builder called year 1, 0. So this is here already year 1, year 2, year 3, and there comes a point when there is no higher density because we have a certain steady die-off rate, and so it seems that after probably 12-13 years looking at this model, that the value of seed survival, which is 20%, and the die-off fraction, which is only 4%. So there we see this equilibrium having been reached. The resulting story makes more sense when we visualize it more realistically. We add the data to the 3D viewer in ArcGIS Pro, which is called a local scene. We can convert the grid cells that have a value of 1, which means they are plants, to points. We can then select one of hundreds of plant species to add a 3D model of the plant. Then we change our camera viewpoint and cycle through the annual growth patterns of this plant. That's all for today. Until next time.